David, it's wonderful to have you with us this morning. David Carroll oversees, he's president and CEO of Gas Technology Institute, well known to us, and been around a long time, and a wonderful, wonderful organization that really is moving the industry forward in a major way. He oversees the company's operations, directs its programs for developing technologies, products, services that really create value for customers in the natural gas and related industries, and of course, as a follow-on to those who are served by natural gas and the natural gas infrastructure. David joined GTI in 2001 as Vice President of Business Development, and he assumed his current position in 2006. Before joining GTI, he held a variety of technical and management positions with Praxair, and Liquefied Carbonic Industries, which is a subsidiary of Chicago Bridge and Iron and Air Products and Chemicals. He became president of the International Gas Union in 2015, and with his term concluding at the World Gas Conference in Washington, D.C. In 2018. That was a wonderful conference, David. It was absolutely marvelous and utterly enjoyable and so informative. He's currently a member of the International Gas Union Management Team, and he served as chairman of the steering committee for the 17th International Conference and Exhibition on LNG, held in Houston in April 2013. And what a visionary at that time in 2013 to not really fully realize the magnitude of what LNG would mean, not just to the U.S., but in a world beyond. For those of us who grew up in an environment in the gas business where we were importing, it was tremendously exciting to see that the worm had turned and that we were in a position of strength and development of the LNG arena, which is really a miraculous and wonderful thing. He is a member of the Society of Gas Lighting and serves on the board of National Fuel Gas, and he's a member of the American Gas Foundation Trustees board and a member of Stanford Natural Gas Initiative Governing Board. So David, delighted to have you here, and it's wonderful to be able to call you one of the real leaders for many, many years before it was as significant, not just for our domestic use, but for international and the impact it's had on our position in the world, not just in trade, but well beyond. So thank you, David, for joining us.
Thank you, Sheila, for that kind introduction. And it's an honor to be part of the event today, and also to follow my good friend Arshad as we talk about some similar themes. Before I begin, though, I want to also express condolences personally and from the GTI family to you, Sheila, and the entire USEA family. You mentioned the World Gas Conference took place in 2018, and Barry was a big part of the national organizing committee that actually hosted a number of events and entertained and informed people from around the world. Thousands of energy executives, government officials, academic people from around the world. And they had a chance to see the United States sort of underneath the headlines. And almost universally, in both surveys and interactions with people, they came away with these impressions. Wow, they were welcome. Secondly, the US was open for business. And third, we were optimistic about the future. And as I think about that event and just reflecting on Barry a bit, those traits and qualities were evident in the way Barry lived his life and pursued his business endeavors. And I think these days, welcoming, open for business, and optimistic about the future are themes and words we all need more of. So we're going to miss Barry, and again, we'll forge on and help cement his legacy. So with that, let me get into the comments here. And first of all, let's be clear. We need clean energy solutions that are implemented on a large scale in economies around the world to achieve the emissions reductions that are going to be required to keep us within 2 degrees of warming. And as Arshad mentioned, there are many technologies that we can deploy right now up until 2030, particularly in areas that reduce the emissions from electricity generation. But to get to levels of decarbonization that are needed post-2030, we need disruptive innovations, economy-wide. So why are we doing this? Well, we care about human progress. Environmental protection and economic growth are the means to that end. And we're motivated to protect the planet while increasing standards of living for the billions of our fellow citizens. And Arshad referenced that in his comments as well. According to the EIA, energy consumption in non-OECD countries will increase by about 70% over the next 30 years, 70%. And that's in contrast to around 15% in OECD countries. So it's pretty clear that the clean energy transitions that'll take place in the developing world will ultimately determine the success that we're going to have in limiting global temperature rise. And for those clean energy solutions to be widely deployed, they have to be low cost. So this is a complex challenge. And at GTI, we're curious about how gases and fuels in existing infrastructure can contribute to low carbon, low cost energy transitions. And we have at GTI decades of experience and know-how that can be leveraged to identify those pathways for new energy systems to achieve those dual imperatives. So what do we know so far? Current work to improve the efficiencies of homes and buildings and passenger vehicles, coupled with more renewables and sensible electrification, is important and needs to be continued. But it's not enough to meet the challenge of deep decarbonization economy-wide and worldwide. Disruptive innovations are needed in parts of our energy system and economies that have so far been difficult to decarbonize, such as heavy industry, chemicals manufacturing, and materials manufacturing, and heavy-duty transport. In these areas, gases and fuels will play a big role in that transition. And equally important to having the gases and fuels is being able to access them where and when you need them. A successful transition to low carbon, low cost energy systems will require approaches that leverage the existing infrastructure and new infrastructure that needs to be built. So we've identified the challenge and are now investing to develop those innovative solutions. So this is a visualization of what we mean when discussing integrated energy systems. Many examples we could talk about, but here's one, where you take renewable electricity, renewable electrons, and move them to a facility that makes hydrogen. And then you take that hydrogen and you feed them into a pipeline and spread them out for a number of different uses throughout that microgrid. But the idea here is that we create tremendous optionality in these integrated systems. But we also have a lot of decisions that need to be made. And it's important to have a system-wide perspective when making those decisions. Thinking systems-wide means identifying who is using which energy sources, when and why. How is energy delivered, and how is it done safely? And systems-wide thinking also helps us connect to the high-level questions, such as, what do we want and value as a society? We're already seeing communities across the country and around the world grapple with this values question. And many are making decisions using small data sets. Their decisions, whether to ban plastic straws, disposable grocery bags, or even certain fuels entirely, are sometimes rooted in what feels good and being able to do something rather than what may have the largest impact toward actually achieving sustainability goals. But because many of these decisions are being made at the local level, we need to arm these local actors with a more data-driven approach that looks holistically at the energy systems that are within their purview. So what if we as technologists developed a larger decision-making network to inform these decisions and also to help facilitate strategic partnerships that would allow communities to work together to use resources more efficiently? The role of local communities and their decision-making power has got to remain in our line of sight as we consider these increasingly integrated energy systems. So economy-wide decarbonization will utilize gases, including, as Arshad mentioned, renewable natural gas and hydrogen. Now, renewable natural gas, or RNG, which is derived by various biological sources, landfills, biomass, etc., can be a drop-in replacement for fossil-derived methane. And we have the technical potential, according to studies, that displace perhaps 6 to 15% of the total natural gas use in the United States, with a technical resource potential of almost 50% by 2040, based on 2018 consumption patterns. This has significant opportunity for decarbonization efforts going forward. Let's talk about hydrogen a bit. We got a good entree from Arshad on that, and we're thrilled to be partnered with EPRI in this regard because we truly think that hydrogen can play a tremendous role in addressing both economic and environmental challenges going forward. So post-2030, it's estimated this demand for hydrogen and other gaseous fuels are going to continue to increase. Even in a world with low oil prices, like we've seen during this current pandemic, the long-term signals are that we're still on that growth path. There's a chart here from Guidehouse produced for the Gas for Climate Commission, which is a group of European gas transport companies committed to achieving net zero by 2050 in the EU. And the chart suggests that hydrogen is going to emerge as a major energy carrier by 2040. Today's hydrogen, as many of you know, is produced by a variety of means, hydrocarbons principally, biomass, or electricity, some with lower carbon footprints than others. And colors are often used to denote varying carbon footprints of hydrogen. Blue hydrogen, which is production that involves the capture and storage of CO2 emissions. Green hydrogen, generated by renewable energy sources without producing CO2 emissions. And gray hydrogen, produced via steam methane reforming with no carbon capture. One of GTI's decarbonization efforts is our innovative low carbon hydrogen production technology. And as part of the HYPER project, which is underway in the UK, we're setting up an advanced industrial scale hydrogen production technology that inherently captures any CO2 arising from the production process, getting at that negative CO2 that Arshad was referring to. It's a generation technology integrated with an end use. And it's important to overcoming several challenges with increased hydrogen production to meet future low carbon needs. But there are other questions that arise as well. What happens when we incorporate more and more hydrogen-rich blends into the existing infrastructure? That work is ongoing, but much more to be done because that piece of the puzzle is increasingly important to ensuring an affordable transition to new energy systems. There we go. applications that use liquid fuels in areas that remain harder to decarbonize. And because of why is that? Well, their energy density is tremendous, and the ease of transport that is provided by hydrocarbon-based liquids. So a continued robust global demand for liquid fuels is going to require decarbonization and getting those new processes to scale to produce low-cost liquids. We do see a continued important role for fossil liquid fuels, but also an increasing role for synthetic liquid fuels. And whether the source of fuels is fossil or renewable, the performance of those fuels must move closer to carbon neutrality. So you might be thinking, what's a fossil hydrocarbon fuel that's carbon neutral? Well, that's exactly the question that we've been asking and exploring here at GTI, in addition to synfuels, because we believe that those hydrocarbons are going to be used, if not here, then in other parts of the world. So again, back to the developing world comment I made earlier, we're going to have to create pathways and technologies that minimize the impact of those fuels globally. And one of the biggest barriers to entry is the high production cost of low carbon and carbon neutral fuels. Fortunately, GTI has some research underway. The first is called very creatively Cool GTL, which is a low-cost approach for converting CO2-rich gas into fungible liquids. Partnering with the US Department of Energy, we're leading a project to build and operate a demonstration plant that converts CO2-containing biomass to jet fuels. It integrates a really novel low-temperature gas reforming process called cool reforming, which is different from steam methane reforming, and couples that with a novel Fischer-Tropsch reactor to produce the liquid. Similarly, GTI's I8² technology converts non-food biomass feedstocks like waste and wood and algae into lower carbon gasoline, jet, and diesel drop-in fuels. This technology is currently licensed exclusively to Shell, and it's going into a plant that's now under commissioning in Bangalore, India. So, sort of in summary, at GTI, we envision a carbon-managed future in which integrated energy systems leverage low-carbon fuels and gases and infrastructure in a way that limits global temperature rise. And by deploying hydrogen, more carbon-neutral fuels and chemicals in ways that build on that existing infrastructure, we can reduce the cost, lower the risk, and provide pathways to global economy-wide deep decarbonization while supporting economic growth. But just reducing emissions isn't sufficient. We need to go beyond that and take greenhouse gas emissions out of the atmosphere. In order to do that at scale, we have to remove carbon at scale. And in order to do that, we're going to have to create value from CO2. That's what we're aiming for, and anything less won't be sufficient. So the game is on, and we're looking for partners, and we hope that many of you on the call will join us in this important mission. Thank you.
Thank you, David, for that very insightful and very thought-provoking presentation. I turn now to Al to see, do we have questions for David upcoming now? And I have one for you, David.
Yes,
Are you finding this? Are you finding with the obvious downturn in economies worldwide, are you finding the same enthusiasm for research, looking towards the future, and the decline in use of fuel, for example, in aviation, the same enthusiasm, just because of the economy and the other challenges at the moment? Do you find that the wheels keep turning and there's still enthusiasm for pursuing these options, some of which will require a lot of research and science and initiatives right now, when the shift has been to dealing with COVID and all. So are you finding the same intensity of interest and desire to keep marching forward?
Sheila, the short answer is yes. First of all, globally, there's been a large snapback in energy demand, right? With the exception largely of transportation fuels, air, aviation fuels. So, and there's been some recovery in prices globally, which has given, I think, the companies confidence to continue to invest. Again, many big energy companies think very long term, right? They're making investments for 50 and 60 years. That's one point. The second point is there's a sense of urgency. I think there's a growing recognition, like Arshad mentioned, as you mentioned, as I've mentioned, that we need to get carbon out of our global energy system. We need to reduce it while providing for economic development. And you've seen so many companies, whether it's BP, whether it's Shell, whether it's Dominion, talk about carbon reduction strategies, net zero by 2050, major investments in wind projects, and so on and so forth. Certainly in part because it's the right thing to do, in part because it should be a very good business strategy, and in part because investors and stakeholders are demanding it. And I think because of that, this is a trend that is going to be with us. It's going to be lasting, with COVID, without COVID. And with COVID, the last thing I'll say there is that you have more and more money being pumped from central banks, from governments, to either stabilize economies or stimulate economies. And to the extent that some of that is directed toward energy infrastructure and systems, it's a wonderful opportunity to develop the technologies and get those in place to prepare us for the future.
That's very encouraging and good to hear. We don't want to lose momentum, for certain.
We have one question. David, can you talk about the challenges of building the infrastructure that you said is necessary? There is increasing resistance to new pipelines of all types. So how do we stimulate and realize the development of thousands of miles of hydrogen pipelines and CO2 pipelines? To what extent can we use existing rights of way?
That's a great question, and many of you on the call know that the resistance to infrastructure of almost all types is under pressure, right? Whether it's a wind farm, a gas pipeline, in the future a hydrogen pipeline. So that will continue to be a challenge, and increasingly those discussions are taking place at local and state levels. So I think some of the key things that successful efforts are that actually get some of these approved include effective stakeholder engagement and education, and a recognition, as I mentioned earlier, in this broader integrated energy system of the greater good. If we stop or curtail our ability to deliver natural gas, or in the future even hydrogen, into areas that need energy, we're going to be perhaps forced to use either non-optimal energy sources that could either increase cost or conversely even lead to more local pollution. No clean gas systems, what are you going to do, burn more wood and add more pollution into the atmosphere? So part of it, again, goes back to education. It goes back to effective stakeholder engagement, and also a broader view of this integrated energy system that identifies the costs and the benefits to society at large.